Hello, welcome to the Time-Space Odyssey. I'm Tom, your host, and joining me today is Kim.
Hello, everyone! Today, we will be diving deeper into the fascinating topic of wormholes.
Today, we're embarking on an extraordinary journey, one that transcends the boundaries of space and time as we know it. Picture this, pathways not just to distant parts of our universe, but to entirely different universes. Sounds like something from a sci-fi movie, right? But hold on to your seats, because this is real, cutting-edge science we're talking about. What makes this even more fascinating is that these aren't just theoretical musings. This study, which we will be talking about today, explores the existence of these wormholes within the expanding framework of a Friedmann universe, a concept rooted deep in the principles of general relativity. So what we're looking at here isn't just a stretch of the imagination. It's a stretch of the very fabric of our cosmic understanding. At Time-Space Odyssey, we look into the mysteries of the cosmos, bringing you fascinating research from the ever-expanding universe of science. Every week, we dive into the depths of space and time to explore groundbreaking studies and theories that are reshaping our understanding of the world and cosmos, presenting the topics and finding them in small, digestible formats. From black holes to quantum mechanics and technological innovations, we're here to shed more light on the complex and often mind-bending concepts that define our universe. All right, so have you ever fantasized about stepping into a universe where time and space form pathways to distant cosmos or alternate universes?
Always. That sounds like something straight out of a sci-fi movie.
Exactly. But guess what? This isn't just a figment of imagination. Recently, RUDN University made a groundbreaking revelation. In October 2023, Kirill Bronnikov and his team opened up a new chapter in our cosmic understanding. They published this study called Possible Wormholes in a Friedmann Universe. And it's not just any study. It's about the potential existence of traversable wormholes. We're talking about cosmic tunnels here, connecting parts of the universe or even different universes.
Hold on. Can something actually travel through them?
That's the twist. This idea has been floating around for about a century, thanks to general relativity. But this team at RUDN University took it further. They're exploring wormholes in a Friedmann universe that's a model of an expanding universe filled with dust-like matter.
Okay. So what's the catch?
The real challenge is proving that these wormholes aren't just theoretical constructs. They're looking into whether they're actually traversable. The team dived deep into the Lemaître Tolman Bondi solution. It's this complex model describing how dust evolves in our universe.
All right, can we simplify a little the Lemaître Tolman Bondi solution?
Imagine the universe is like a big, expanding balloon. The Lemaître Tolman Bondi solution, LTB for short, is a way to describe how different parts of this balloon expand at different rates. It's a bit like having patches on the balloon that can stretch more or less than others. The LTB solution comes from Einstein's theory of general relativity, which tells us how gravity works. According to Einstein, big objects like stars and planets can bend space around them. The LTB solution applies this idea to the whole universe, but instead of stars and planets, it focuses on huge amounts of dust. In this case, dust doesn't mean the tiny particles you find at home. In the LTB solution, dust refers to very simple matter spread out all over the universe. This dust doesn't push or pull in any complicated way, it only has gravity. The key idea of the LTB solution is that this dust-filled universe doesn't have to expand the same way everywhere. Some regions might be denser with dust, and others less so. This difference can make the universe expand faster in some places and slower in others, just like some parts of our balloon stretching more than others. So, in simple terms, the Lemaître Tolman Bondi solution is a mathematical way to describe a universe filled with simple matter where different parts can expand at different rates because of how much matter they contain. The RUND team added a twist to it, considering an external electric or magnetic field and a non-zero cosmological constant. Non-zero cosmological constant is a number that Einstein first thought of and then rejected, but it turns out to be really important. This constant is a way of describing an invisible force or energy that's everywhere in space and makes the universe expand faster. You can think of the non-zero cosmological constant as an invisible and mysterious force that's everywhere in space, pushing it to stretch and expand more and more. This goes against the pull of gravity and is one of the biggest mysteries in understanding the universe.
Okay, let's go back to the research on the wormholes. Did the RUND team find something concrete by adjusting these theories?
Their research showed that photons, the particles of light, could actually travel through the theoretical wormholes. But there's more. They expanded this idea to a multi-universe system. Imagine a mother universe connected to daughter universes through these wormholes. It's like a cosmic network of universes almost glued together by wormholes.
So it is like a cosmic network, a bit like a string of bubbles, connected and glued together by wormholes?
Each bubble could represent a universe connected by the glue, and the connection points between them represent the wormholes.
So, can anything travel through these wormholes, or are there conditions?
Good question. It turns out it depends on specific parameters at their entrances and the initial conditions. It's a delicate and fascinating balance. This could really shine a light on some of the universe's mysteries, like the cosmic microwave background or cosmic voids. It's an exciting blend of theoretical physics and astrophysics. It's bringing us closer to understanding the complex web of our universe.
Maybe one day, this research could lead to new ways of exploring the cosmos. The universe just got a whole lot more interesting.
Couldn't agree more. The possibilities are as endless as the universe itself.
As we wrap up today's episode, we want to thank you all for tuning in. It's been a fascinating journey through this topic. We hope you found this brief episode enlightening and thought-provoking. Remember, the conversation doesn't end here. We encourage you to keep exploring, asking questions, and seeking out new knowledge. Join us next time for another deep dive into the stories and ideas that connect us all.
Until then, stay curious, stay engaged, and take some time to look up at the stars and wonder. This is Time Space Odyssey, signing off. Keep listening, keep learning, and be kind to one another out there. Goodbye for now.